will try to explain what is VTH. It is a threshold voltage. So we will try to understand what we mean by threshold voltage, which is also represented in short form as VTH, where V stands for voltage and TH means the threshold voltage. So let us consider we are having one PMOS or NMOS. This is one MOSFET. This is MOSFET. Why we call it MOSFET? We say because it is consisting of two parts. One is MOS and another is FET. Why this MOS says that metal oxide semiconductor. So there is some layer here, okay, and this layer is a metal or a polysilicon. So usually because of this metal part here, this occurs here. So metal, and between this metal and this, below this we are having the semiconductor, mostly silicon, and between this metal and silicon there is oxide, usually SiO2 means silicon dioxide. So this oxide comes from that part, and then we are having this semiconductor that is below this oxide. So there is this metal and there is this semiconductor, this is metal, and between these two there is silicon dioxide, that is metal oxide semiconductor. And what is this FET? FET means the field effective transistor, means we are providing the electric field from this terminal, that is also said as gate. Okay, so we are having here one device that is said as a MOSFET. Why it is said as a MOSFET? We have learned it is metal oxide semiconductor and field effective transistor. So there are two types of MOSFET. Okay, so one is NMOS and another one is PMOS. So if this we are having this another representation of this MOSFET. So this is a this is said as a body or substrate. Okay, so if this body is of N type, if this body is of N type and there are some well, or we can say pocket, or some diffusion done here in this particular body. Let us suppose this is NMOS and these wells are of PMOS. Okay, so then this device will be a PMOS device or PMOSFET. Okay, and here we are having the gate that we have studied here. And if this body is PMOS and these wells are NMOS, then it is a NMOS device. Okay, so based on what type of device, what type of material we use for well or diffusion inside body or substrate, that becomes the device. Okay, so what is NMOS and PMOS? Like, what is the difference between the two? So it depends on like this what type of material is used for body and what type of material is used for this this small diffusion wells here, or also pockets, we can say it. So these are complementary. If this is of N type and this will be of P type, if this is of P type, this will be N type. Okay, so in NMOS, the majority carrier is electrons. Okay, in PMOS the majority carrier is holes. Okay, so now basically we have to understand, we have to understand like VTH, threshold voltage. So this is a symbolic representation of PMOS. This is a symbolic representation of MOSFET device, where this is a gate, this is a, let us say, drain, this is source, and there is one terminal you know uh, here also, that is body. So these are the terminals, like we can control this device by applying various voltages, or we can say bias. Okay, so let us name it as or fix it as NMOS. So this body will be PMOS, and this drain will be NMOS, and this will be NMOS. Okay, so usually this drain is connected, for the NMOS device it is VDD, and this source is ground. So now if we apply a VDD here, like we apply here 1.2 volt, and here is a ground, so there is a potential difference between these two nodes, so the current should flow. Current should flow means electrons should flow from ground to here, and the current direction will be from drain to source. But it will not occur. Why? Because when we are having, let us say it as it is NMOS, this body is of PMOS, this body is of PMOS, so means here we are having holes. Okay, here we are having holes, and these holes will not allow this electric field from VDD, means drain side, to reach the source. Okay, means here we are having the ground, means uh, this field will not be possible to attract the electrons from this ground towards the drain, because we are having here majority carriers, that is from this PMOS, as holes, but we want here electrons. So basically we have to invert this part, and this part is also said as a, we have to create some channel, and that channel will be created using a bias applied at gate. So what we do, we have now this NMOS, we are having here VDD, we are having here ground, it's set as a drain terminal, this is source terminal, and here we are having gate, and we, let's suppose we are having here 1.2 volt, this is 0 volt, and now we have to remove the holes from here and have here electrons, but electrons are minority carriers here. Minority carriers means those are very less. Okay, so we apply here positive voltage, means let us suppose we apply here from 0 to, we are going towards 1.2 volt, and when we apply the positive voltage here, what happen, these holes will be reflected, means it will be the electrons will be attracted more towards here, towards the gate, and the these holes will be moved down, means it will get the reflection, means it will not get the attractive force, it will be moved down, and the electrons will be here, and very less electrons will be initially here when we are moving towards from 0 to 1.2, and now electrons will be supplied by this source also. So we are having some channel here in which we are having the electrons only, and these electrons will start moving from the source towards the VDD, and there will be some point or particular VDD, particular voltage at gate, uh, which will invert the channel from holes to electrons, at which current starts to flow from VDD or drain to source or ground. That particular that particular voltage is said to as VTH, means the threshold voltage. Okay, let us understand again. This is drain, and this is source. We want to move the current from this drain to source. Let us say it as IDS, but it is not able to flow this current. Why? Because the electrons are not able to move here, because we are having here majority carriers of, because of the body, that is PMOS. We have to remove this holes from here and make only the electrons here, means we have to create a channel of minority here, channel of minority. The and it will be possible by applying the positive voltage here, and positive voltage at which the positive voltage at which we are able to have here sufficient number of electrons so that the current starts to flow from drain to source, and that particular voltage is said as a threshold voltage, means when this gate to source voltage is greater than VTH, the current starts to flow from drain to source. So VTH is a voltage between gate to source at which current starts to flow, that is IDS. Okay, and this VTH is with respect to the source. Why? Because this source is at ground.